Hi, this is Mrs. Vrobel. This is Chapter 14, Part 1 of Mixtures and Solutions. So today we're going to be learning about the difference between mixtures and solutions, and I have some examples from my kitchen, and you're going to determine whether or not they're a mixture or a solution. So I have an example of unsalted butter. I have some milk that's right from the fridge. And I have a bottle or jar of mayonnaise. So my question is, which one of those is a mixture? Which one of those is a solution? So here is a list of solutions. Which one of these do you think is a solution? Which one of these do you think is not? And I'll tell you right now, there's probably multiple solutions in this set of examples. Okay, in order to be considered a solution, it has to be homogeneous and it has to be a single phase. So technically, if it's not one phase, it's not a solution, it's probably a mixture. So always look to see, is it a solid, is it a liquid or a gas? And please note that it doesn't necessarily have to be a liquid. It could be a solid, it could be a gas. Okay, now we use terms to help us understand what is a solution, what are parts of a solution. Notice that a solute dissolves in a solvent. So solute is the material that is going to become part of the solvent. If you're making sugar water, notice that water is the solvent and the sugar is the solute. Now, be careful, not every solute is going to be solid. It could be liquid, it could be a gas. Notice if you're making salt water, water is the solvent, the salt is the solute. Okay, now you have to be careful because your textbook says that the substance that's in the largest percent or largest amount would be considered the solvent. And yes, technically that is true. However, you're going to find that sometimes that is not true. If a solid is added to a liquid, notice that you get a liquid solution, and the liquid, it's considered the solvent, but you can have what we call a supersaturated solution, and what happens is there's more solute than is expected that is dissolved in the solvent. So here we have an example where we have 109 grams of sodium hydroxide in 100 grams of water. Please note that the sodium hydroxide is the solute, but the liquid solution is water, or the solvent is water. Okay, here's some solutions here. And please note that anytime you have a solution, the solvent determines the phase. Oops. I guess what I was going to do is, let me ask you if you can think of examples of liquid solutions where there's a solid, liquid with liquid, gas with liquid, gas with gas, solid with solid, liquid with solid. So think in your everyday life, where do you have these types of solutions? The first one is easy. We just did that with sugar water or salt water. Liquid with liquid. You might have a liquid solution where there's a liquid solute in a liquid solvent. I'll give you a moment to think about that. Okay, here is your book's example of some solutions. So notice that we could have gas with gas. So like I said, don't assume that you're always going to have a solid with a liquid, okay? And air, obviously, is a great example of a gas with a gas. And they're counting whichever is the most of the solvent, or the most amount is the solvent. In air, there's more nitrogen than there is oxygen, and that's why they call nitrogen the solvent. Carbonated water, I drink that all the time. Notice that the solute is a gas, so I'm injecting carbon dioxide in my water every time I make a soda stream. Ocean water. Notice that ocean water, we have gas dissolved in water. Here's an example of everyday liquid solute with liquid solvent. And by the way, antifreeze is toxic. I'm sure you've read instances where people have been poisoned by antifreeze. Vinegar. Vinegar is an example of a liquid solute with a liquid solvent. And then I'll just hop down to steel. So notice that steel, we're talking about a solid solution where we have carbon, which is a solute, and it's solid, and it's dissolved in iron, which is solid. Now, you're going to come across heterogeneous mixtures. So please note that heterogeneous mixtures, we do not necessarily have one phase. So that's a big difference. And that means that you can actually separate out the individual substances. You may have a suspension where you have particles that settle out, sort of like the snow globe. When you shake up the snow globe, you see the snow, eventually it settles to the bottom. That would be considered a suspension. Okay, colloids. Now colloids are heterogeneous mixtures, and colloids, the difference between a suspension and a colloid is the fact that colloids remain in the mixture. They don't settle out. And I'll give you an example of a colloid in class, and I'll show you that they exert a certain property. Please note that the most abundant substance is the dispersion medium, okay? And colloids, we can actually measure the size of the particles, and we can identify their phases too. Okay, so here are some colloids, and there's some interesting examples of colloids. Blood, where essentially you have solid, which is your blood cells, dispersed in a liquid. We have foams, we have marshmallow, we have individual pockets of air that are dispersed within a solid marshmallow fluff. Here we have smoke. So you have the ash, which is the solid, and it's dispersed in the gas, which is the air. So these are all examples of colloids.